Okay, so I've tried to get a kickstart on this problem just to take up less video time. So Jay is constructing an open box that's 5 inches wide, 8 inches long. He cuts squares of equal sizes from each corner, x by x by x by x. Then folds up the sides of the box along the orange dotted lines and the green dotted lines. Write and simplify the polynomial function volume for the box. Well, if this is 5 and he cuts off this x is taken away from it and this x is taken away from it, you'd be left with 5 minus 2x. If we look this way, this whole thing from here to here is 8, but if we take away that x, take away that x, 8 minus 2x. So that's where 8 minus 2x times 5 minus 2x times the height x, because if we fold these edges up, our height of our box would be these x's. Now we need to multiply it. So I'm going to focus on these first, get my answer, FOIL, out first, 40, outside, inside, last. I'm going to add my like terms and rearrange this a little bit. I'll take this space, minus 26x plus 40. Remember, there's a little x. I'm just going to put it in the front. Distribute it. I get 4x cubed minus 26x squared plus 40x. And that would be my volume function right there. Next one's a lot of work. Got to multiply these. This is a binomial times a trinomial, which tells me to build one of these. Now you don't have to. Some of you said you don't like to, but I like it. So x and 2y, x squared minus xy, 3y. Multiply those together, multiply those, multiply those. Multiply these. Notice I'm putting my x's in front of my y's. That helps me look for like terms later. Minus 2xy squared and then 6y squared. Look for like terms. So x cubed. 2 of them minus 1 of them is 1 x squared y. Done with those. 3. Okay, now I'm going to go to this one. I thought those were like terms. Minus 2xy squared. Doesn't have a like term, plus 3xy, and then plus 6y squared. So we look for that answer, and where is it? So it's a little confusing, but I see the x cubed, x squared y, 3xy, 3xy, negative 2xy squared, boom, 6y squared. Looks like we got a match. Tackle this next beast. Use division. Now it doesn't say what kind, long division or synthetic. Synthetic's easier. So I look at this and I say, hey, I'm going to put whatever causes this term to be 0. So that's a negative 3 plus 3. So negative 3 in the cheap monk nest. Then I put it in descending order. Notice I didn't have to put a 0 in here because it goes 3, 2, 1, none. Drop the 1, multiply, add. Multiply, add. Negative 12, add. So there's my remainder. How do I write my answer? Well, remember, that's a 3. So that represents 1x squared minus 2x plus 4 plus my remainder over my divisor. And there's that one. Number 34, we're going to use the remainder theorem, which says we started out kind of like this, and we say, what causes this one to be 0? That would be a 3. Now, we could go through the whole process and just look for our final remainder, but the trick is, all you got to do is plug this in. So 3 to the 4th is 81. 3 squared is 9 times negative 5 is negative 45. 3 times negative 6 is negative 18. Minus 10. So this and this is negative 55, plus this is negative 63. So I got 8 minus 63. which is negative 55, and there's my remainder. Next problem is very similar. It says, is x plus 2 a factor of this? If it is, write it as a product of two factors. So we could use the shortcut, but if we have to write it as a product of two factors, we better go up here and use synthetic division. So we start here. What causes that to be 0? Negative 2. 2, 5, 5, 6. Up the 2, multiply, add. Multiply, add, and then we get negative 6, we get a 0. Because this is a no remainder, we say yes, it is, but we're not done. We got to pay attention to the instructions. So x plus 2, so p of x can be written as this times this, and this represents 2x squared plus 1x plus 3. That's the other factor. And now we're done. Number 36 should be an easy one. How does this graph compare to the parent function? Well, if you look at it, this is a y equals x cubed. There's our parent function. It looks like this, but they're not asking us to graph it. This right here, instead of a 1, it's a 2. So that means it's a vertical stretch by 2. That moves it left 1. That moves it down 3. And that's all they want. You just got to know your rules. So 37 says the volume of a refrigerator in cubic centimeters is given by this. Write the new function for the volume in standard form. That's a fancy way of saying multiply this all out. So I'm going to tack these two, FOIL it out. X times x is x squared. Outside is negative 2x. Inside is 1x. 1 times negative 2 is negative 2. I'm going to clean that up. But I can't forget there's a little x. Now I'm going to distribute that through. So a new function for the volume, so I'm going to go v of x equals x cubed minus x squared minus 2x. There it is in standard form. So the instructions for 38 give you a little clue. What are the real and the complex, which means you're probably going to get the letter I in your answer. It's part of your answers. One thing I said was, when you're doing these problems, that's a huge clue. You're not done until you have 3 answers. Well, if we look at this, I said if there's 4 terms, try to factor by grouping to get started. What can we take out of here? X squared. What's left? X plus 3. Notice this matches this, so we're going to take a 1 out of this, and you get x plus 3. When these match, that's a good thing. But now I've taken those out, I'm left with x squared plus 1. This is good old factor by grouping. This should be an easy one. What plus 3 is 0? Negative 3. This one's where it's going to be a little challenging. It's like, hey, I can't really look at that, so I'm going to literally set it equal to 0. Subtract 1 from both sides. X squared is negative 1. Remember, we need 2 more answers. Here they come. Bada boom, bada bing, do the right thing. And that's just plus or minus I. So that'd be I and negative I. Done. Okay, this is a reciprocal function. The graph of y equals 1 over x, they're not asking us to graph it, is translated 3 units up, 2 units to the left. What is the new equation? Well, remember, here's our x value. If we want to move that 2 to the left, we're going to go 1 over x plus 2. Then if we go 3 up, we just put a plus 3 on the end. And that's it, you guys. So number 40 takes us into the world of inverse variation. So it means there has to be either this or x times y equals k. I'm going to piggyback this one because it just jumps out at me. 3 times 5 is 15. 15 times 1 is 15. half of 30 is 15. So this problem is asking you 10 times some r has to equal 15. I'm piggybacking this rule here. Divide by 10, divide by 10, and I get r is 3/2. There's my answer. Okay, so this section I don't think we got to because I believe it's connected to 4.2, which we said we don't have time to do. I'm still going to show you the rules and help you understand especially the horizontal asymptote feature. You guys should know the vertical asymptote feature because we talked about it. The vertical asymptote feature is where you cannot have a 0 in the denominator. So let's talk about that first. So we look at this right here and we say, hey, we can factor that into x plus 7 and x plus 2. So we say, hey, x cannot equal negative 7 and x cannot equal 2 because those values would cause a 0 in the denominator. Notice I'm not even worried about the top. What can't x be? Well, whatever causes the 0 to be in the denominator. So that's telling me for letter A, x equals 7 and x equals 2, negative 7 would be my vertical asymptote. Let's go over to this one. This one's not factorable. In fact, if we actually tried to solve this, we'd go 2x squared plus 25 equals 0. We'd get 2x squared equals negative 25. Divide by 2, divide by 2. We'd get x squared equals a negative, which means if we go like this, we would get the letter I, which means imaginary number, which means it doesn't exist. So there are no vertical asymptotes for this one. Now let's talk about horizontal. This is something we never got to, but I'm going to show you anyways. Here are the rules for horizontal asymptotes. If the top degree is less than the bottom degree, your horizontal asymptote will be y equals 0. So let's check it out. Top degree less than bottom. Notice this is to the first power and this is to the second power. So that's less than this. So our horizontal asymptote would be y equals 0. Now let's look at this one. Our top degree and our bottom degree are equal. And if they're equal, then what you do is you take the coefficient of your highest degree term, coefficient, and you just take those two values and you say y is equal to 3/2, which means if you were to graph it, you'd go up 1.5 and there'd be like a roof, and the drawing would come in and try to touch it, but it could never touch it. And just for kicks and giggles, if the top degree is greater than the bottom degree, there are no asymptotes. For example, if I had if I had like 3x to the 7th plus a whole bunch of stuff all over 4x to the 5th plus a bunch of stuff, there would be no horizontal asymptote. I might throw these in as bonuses, so do your best with the rules that I just taught you. Okay, up to number 42. Find the sum or the difference. Well, the only way we can do that is finding common denominators. So if I had 1/2 plus 1/3, I know my common denominator would be something 6 plus something 6. Where'd this come from? By multiplying these two denominators together. So I know my new denominator is going to have to be x plus 6 times x minus 1. And then for this one, I'm going to have to do the same thing. 3 over x minus 1, I'm going to put parentheses around those, equals, and again, I've got to create common denominators. So that tells me, what do I got to multiply this one by? X plus 6. But if I multiply the bottom by x plus 6, I got to multiply the top by x plus 6. So I distribute that through. I get 3x plus 18. Same thing here. If I need this from this, that means I got to multiply this by x minus 1 to give me this. But I got to multiply this by x minus 1. So I distribute. I get 2x squared minus 2x. Notice I got common denominators. So now I can add the numerator stuff, the like terms. So 2x squared, notice I've got like terms here, so 3x minus 2x is x. And then I get plus 18, all over my common denominator. And that finishes this portion. We're almost done. A few more problems.